Okay, guys, this is going to be the video where we talk about the first three questions for the AP Stats free response. So this one is about 34 college students and the amount of money they spent on textbooks for the current semester. And this is called a stem and leaf plot. All right, it says stem plot, but we always called it a stem and leaf plot. And if you forgot how to read it, make sure you refer to that key, right? It tells you the stem is the hundredth place, and then the leaf is going to be what's in your 10th place. All right, so part A says to describe a procedure for identifying potential outliers and then use the procedure to decide whether there are outliers among the responses for the money spent on textbooks. So I'm just going to walk you through the procedure that we did when we learned how to do this in our first unit. All right, so step one is to find the interquartile range. All right, to find the interquartile range, you need quartile 3 minus quartile 1. So the first thing that I'd notice is that it's 34 college students. So if I take 34 and divide that by 2, I get the 17th and 18th student. All right, that would give me the median for my amount of money spent on textbooks for these students. Now I want the medians of the bottom half of the data and the medians for the top half. So I'm just going to show you where the median is. If you count from that first number, right, this is the first number, and count to the 17th and 18th, you get right here is the median. So the median is going to be between 280 and 290, which is 285. So to find the quartile 1, you're going to count halfway from the first number to that 8 just before the median. So that would be 17 divided by 2, which is 8.5. So you round up to the 9th data value. All right, so if I count from the 2 to get to the 9th one, I get 1, 2, 3, 4, 5, 6, 7, 8, 9. The 9th one is that 8. So quartile 1 is $180. All right, with that same understanding that it's the 9th one, if I count from this 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9, the 9th one on the upper half of the data is 390. So quartile 3 is 390. Subtracting those gives you the IQR, which is $210. Step 2, right, that's where you take your IQR and you multiply it by 1.5. So in this case, I'm doing $210 times 1.5. Half of 210 is 105. So that's going to be 210 plus 105, which is $315. All right, now 315 is what we're going to use to find our next step, which is to find the fences. All right, and once you find these fences, this should give you an idea of how you're going to figure out if you have any possible outliers. So the lower fence, which I'm going to write as LF, is quartile 1 minus that $315 that we just found. The upper fence is quartile 3 plus $315. So if I take 180 and subtract 315, that's going to be a negative number, right? And I'm not really concerned about what it is, because if I look at what this data is, it's how much money students are spending on textbooks, and you're not going to spend a negative amount of money. So that means we don't have any outliers on the low side. So no outliers on the low side. Let's do the upper fence. Right, this would be quartile 3, which is 390, plus 315, which is going to be $705. So now when I look at my data, I'm looking to see if there are any students that are spending more than $705. And there is. There's one student spending $810. So we have one outlier, and it's that student that spent $810 on textbooks. All right, so that's the process and using the procedure to figure out if there are any outliers. Now, part B says, based on the stem plot, write a few sentences describing the distribution of money spent on textbooks for these 34 students. So the moment you're talking about a histogram, a stem plot, anything that's describing categorical data, and you see the word distribution, you should be thinking shape, center, and spread. Okay? So when I look at this stem plot, it looks like it is unimodal. It has one kind of main hump. What was that? Anyway, If you do look at this stem and leaf plot, you'll see there's one main hump, and then the tail kind of moves off to the right. So this is going to be skewed to the right. So I'm going to write down the shape of the distribution for money spent on textbooks is unimodal and skewed right. And then for the center, we already mentioned the median when I was trying to find the quartiles. The median is in between 280 and 290, which would be 285. So the median amount spent on textbooks is $285. And finally, for the spread, we actually already found a measure of spread. We found the IQR, so let's just use that. The interquartile range for the amount spent on textbooks is $210. All right, key thing when you're doing this is make sure that you're doing the shape center spread, but also don't forget, always in context. So if you're just writing down the shape is this, the median is this, the IQR is this, but you don't mention that it's about the money spent on textbooks for these 34 students, then you're not going to get the full credit. All right, that's it for number one. Let's go to number two. Now, number two, we actually did this problem, I think, in the review, maybe even on the actual exam for our most recent unit. All right, this is saying that we're looking at the relationship between two quantitative variables, the distance a house is from city center, so from downtown, and the other variable is the selling price in thousands. And if you look at this scatter plot, it's not asking you to do this, but if you were to ask to describe the association here, you would make sure you need to mention direction, form, and strength. Okay, and it looks like this is negative, it is linear, and it looks strong. All right, so just keep that in mind. It didn't ask you to do that, but the AP exam might ask you to do that very soon. Now, it wants us to construct and interpret a 95% confidence interval for the slope of the least squares regression line. So this is called a linear regression T interval. All right, and using our formula from our understanding of confidence intervals, we need our sample statistic, which is our B bar, so our sample slope, plus or minus T star with our degrees of freedom times the standard error of B bar. All right, now the computer output they gave us, right, so this right here is going to give us the sample statistic, right, our slope of that linear regression line is negative 2.158 plus or minus, I don't know T star yet, times the standard error, which is 0.149. We've done this already a couple of times in the multiple choice questions, but when you go find the critical value, right, this is a 95% confidence interval, so I'm looking for 2.5% in each tail. All right, don't forget when you're using the T distribution model like this one, you do have degrees of freedom, and for a linear regression, T interval or T test, that degrees of freedom is the sample size minus 2. And this problem says there are 20 houses that they used for this analysis. So 20 minus 2, which is 18. All right, so now I'm going to go to technology to figure out what my T star is. So go to second, distributions. I'm doing inverse T, which is number 4. I'm typing in 0.025 for the area, and the degrees of freedom is 18. That tells me that my T star is 2.1009. All right, so now all it is just doing some more typing to find the actual interval. First thing I'm going to do is multiply the critical value times the standard error, which is called the margin of error. So times 0.149. So that's my margin of error, 0.313. and then you take your statistic, which is the negative 2.158, and add it and subtract it. All right, so subtracting it gives me negative 2.471, and then adding it gives me negative 1.845. All right, don't forget to do the sentence here that I am 95% confident that for each mile a house is farther away from the city center or downtown, I expect the price to decrease on average between $1,845 and $2,471. All right, so that's all of the mechanics as well as the interpretation of this interval. Now, there's another part to this question. Part B essentially says, if the real estate agent believes that the selling price decreases by about $2,000 for every mile, does this interval contradict this real estate agent's belief? And what you notice if you look in the interval is that negative, right, decreasing by 2,000. So negative 2 would be in our interval, right? Negative 2 resides in our interval. So this interval does not actually contradict the agent's belief. So don't forget to put context here. Don't just say no. This interval does not contradict the agent's belief because negative 2 is in our interval. All right, so that's it for question number 2. Now, question number 3, you guys can go if you want to go now. Question number 3 is going to be talking about this campground at River Run. And the way that they're kind of showing you these histograms is you've got campsites where the campers don't have any young children. And then we have other campsites where there are young children. It says this is 20 had young children and 40 did not have young children. Bye, guys. Have a good weekend. All right. So just keep that in mind when you're reading these. And it says that all of these histograms were made with the idea that it's relative to an exit time of 9 a.m. Okay. So if I see negative numbers, that means people are checking out of their campsites before 9 a.m. If I see numbers that are above 0, so positive numbers, that means they're checking out after 9 a.m. or checking out late. All right, so that's kind of the gist of this question. Now, part A, we're going to do 2 things. And you'll notice that it says consider both histograms, and it says 60 sites. The moment that I see it says both histograms and 60 sites, that makes sense because we have 40 and 20. So I'm going to probably be looking at both here. How many of the 60 sites had an exit time before 8:30 a.m.? Well, I notice 8:30 is before 9 a.m., so it needs to be negative numbers. It needs to be before negative 30, so numbers below negative 30. The first thing I look at with the young children, there aren't any people that had young children that were able to get out of their campsite even at 9 a.m. That would be 0. So it's not. I don't even look at the histogram to the right. Histogram on the left does have some negatives. I've got, let me just show you my colors here to help. So this is blue. So this one here has 2 that checked out between 8 a.m. and 8:15. And this one here has 1 that checked out between 8:15 and 8:30. If I go to the next one, so between 30 minutes before and 15 minutes before 9 a.m., that would be 8:30 to 8:45, which is not before 8:30. So it's actually just 2 plus 1, those first 2 bins to give you 3. All right, let me change to green for the next one. How many of the 60 sites checked out after, 11 a.m. or after that? So past 2 hours. So 2 hours past 9 or more. So that would be 1:20 or more. And they both have some. So this one here, right? That's 1:20 or more. Same with that one. And this one and that one. So if I add them together, that's 4. So the first one is 4 plus 1 plus 2 plus 1. So that's what, 5? That's 8. There are 8 sites that had an exit time of 11 a.m. or later. That's way past the target time of 9 a.m. Okay, now part B. Part B says to compare the distributions for the exit times for those without young children and those with young children. So again, this is another shape center spread problem. All right, and don't forget, always in context. Now, because they want without young children and with young children, you've got to do shape center spread for both of them. The way that I always did this was I did them at the same time. So I did the shape together for both, and the center together, then the spread together, but it's your choice. So if I go to the shape of these, or if I just look at the histograms here, where'd they go? There they are. If I look at the histograms, it looks like both histograms are unimodal. All right, but I would say the one with young children looks roughly symmetric, and the one without young children looks like it's skewed to the left. So I'm going to write that down. All right, so the shape, all right, let's say the shape of exit times for without young children is unimodal and skewed left. The shape for with young children is unimodal and roughly symmetric. Okay, so that takes care of the shape. The next thing I'm going to do is the center. And you know me, I like to do the median, and I can calculate both of these medians separately. So remember, this one without young children had 40. Divide that by 2, and you get the 20th and the 21st data value. So the average between those two, let's see. So this is 2 plus 1 is 3 plus 2 is 5, 7, 9. 9 plus 3 is 12. 12 plus 3 is 15. 15 plus 2 is 17. 17 plus 4 gets to 21. So the 20th and the 21st data values will be between 60 and 75 minutes after 9 a.m. So the median exit time for without young children is between 60 and 75 minutes after 9 a.m. Let's do it for with young children. All right, so that's 20 divided by 2, which is the 10th and the 11th. All right, so that means I'm going to have 2 plus 3 is 5, plus 4 is 9, 9 plus 5 is 14, so the 10th and 11th are in that bin, which is 90 to 105. All right, so the median for with young children is 90 to 105 minutes after 9 a.m. Okay, now the last thing is the spread. You could, if you wanted to, find the quartiles and find the IQR like we did in number 1. I just think that's wasting your time here. The easiest measure of spread to find is the range. So if you just look at both of these, you can see that those without young children is way more spread out, going from potentially leaving by around 8 a.m. or a little after 8 a.m., all the way to leaving possibly up to 2.5 hours after 9 a.m. For the young children, the ones with young children, no one is leaving before 9:45. So that's going to go from about 9:45 to about 2.5 hours after, so 11:30. So I think the easiest one to do here is the range. So the range of exit times for without young children is between 8 a.m. and I think it was 2.5 hours after. Let me make sure. Yep. So 2.5 hours after is 11:30. And then for with young children, it was 9:45. So again, no one's checking out on time. And 11:30. All right, and that's it. So the key thing for this, I know it's a ton of writing, guys, is shape, center, spread in context for both of these histograms. Now, the last question here says, if you look at both histograms, what is a reasonable estimate for the median exit time for the random sample of 60 sites? So if they're all together, right, I need to find, if I go back up here to the histograms, and I'm treating this as they're all together, that would be 60 divided by 2, which is the 30th and the 31st data values. And so again, it's not too bad to start. I'll use a different color, I'll use red for combine. Not too bad to start because when you look here, excuse me, none of the campsites with young children even got out of there until 9:45 at the earliest. So I'm just going to start with the without young children. But then when I get to this 45 number, I need to make sure I bring in with young children. So we got 2 plus 1 is 3, plus 2 is 5, plus 2 is 7, plus 2 is 9, plus 3 is 12, plus 3 is 15. Okay, here we go. The next one here, 15 plus 2 is 17. And then this one is 2 is 19. Back to the without young children for the 60 to 75. 19 plus 4 is 23. 60 plus 75 right here is 23 plus 3 is 26. Then the 75 to 90 is going to be 26 plus 4 is 30. There's my 30th number in between 75 and 90. Then back over here, 75 to 90 would be 30 plus 4 is 34. So the 30th and the 31st is going to be between 75 and 90. So the median exit time for all 60 will be between 75 and 90 minutes after 9 a.m., which that's going to be 10:15 and 10:30. All right, so that's it for the first 3. Check back for videos about the next ones.